It is important for mariners to have reliable communications and accurately determine the position of their vessel and other nearby vessels to maintain the safety of navigation of ships. Precise positioning and access to emergency services prevent accidents and save lives. When ships are at sea, they are out of reach of terrestrial cable communication networks. The only way of communications for ship and navigation is by electromagnetic waves. Electromagnetic wave is propagation of alternating oscillations of electric and magnetic fields. The main characteristics of an electromagnetic wave are its amplitude and frequency. Amplitude of electromagnetic wave is responsible for strength of received signal. Frequency is responsible for characteristics of propagations of electromagnetic wave. And technical characteristics of equipment included in communicating systems such as antenna systems, transmitters, receivers, etc. Microphone transforms sound and electric signals, so the form of sound oscillating and the form of produced electrical oscillating are the same. That electric signal produced in microphone is shaping the courier signal, and that process is called modulation. If the signal from microphone is shaping the amplitude of the courier signal, it is process called amplitude modulation. If the signal from microphone is shaping the frequency of the courier signal, it is process called frequency modulation. Amplitude modulated signal on the frequency scale is located as it is shown on the picture, on the both sides of frequency of carrier signal. That new modulated signal is called double sideband. One of the sidebands is sufficient for communication, and there is no need for the other one. So, in the modulating process, one of them is usually removed by filter. That new signal is called single sideband or SSB. Modulating carrier signals of different frequencies, with signals from microphones, they are distributed on the frequency scale and can't interfere with each other. So on that way, it is possible to communicate independently through the same area at the same time for many of subjects. There are 3 frequency bands for radio communications on ship. Medium frequency band, MF, high frequency band, HF, and very high frequency band, VHF. Frequency modulated signal is much wider on the scale and can't be used in MF, HF, and VHF bands because there would be enough space for very few channels. Frequency modulation is used in ultra-high frequency band, UHF. Medium frequencies MF designated for marine communication range between 1605 kHz to 3800 kHz and are called T-band. High frequencies designated for marine communication range between 4000 kHz to 27,500 kHz and are called U-band. This is divided into the following subbands: 4, 6, 8, 12, 16, 18, 19, 22, 25, 26 MHz. Only the first 5 are used for distress and safety communication. The marine frequency band for VHF radio communication, extending between 156 MHz and 174 MHz, contains 57 individual VHF channels numbered consecutively from VHF channel 1 to VHF channel 28 and from VHF channel 60 to VHF channel 88.